All right, so let's take a look at the difference between hypertonic, isotonic, and hypotonic, and how this is going to relate to our lab. This is a very simplified version. I wanted to break this down and make it easy to understand. So what's in a solution? We need to break down and define the difference between a solution and a solute. A solute is going to be the parts that actually dissolve. Okay, so it's what we're placing in the solution. In a biologic environment, the solution is typically going to be water, and so that is what we are dissolving in. You can kind of think of a solute as being like sugar, and the solvent that we place it in could be like tea. So if you're going to make a sweet tea, the solute would be the sugar, and the solvent would be the tea. Solute, what's dissolving, solvent, what you're dissolving into. Okay, and so here we have W's for the water and S for the solute molecules, because this is what typically occurs in a biologic system, is we're going to be dissolving into water. So does it make sense for the sugar to be dissolved in the water or the water to be dissolved into the sugar? Well, obviously it makes more sense for the sugar to be dissolved into the water. And so that's usually going to be the substance that you have less of to be the solute. If you want to look at it as far as two different liquids when you're dissolving. But we're going to look at some different concentrations here and how we're going to change that into a hypertonic solution, meaning having extra or above, and hypo, meaning having less or below. So here is a cell, and we're going to look at the area in this little box here, the plasma membrane, and zoom that in. Okay, so we have the plasma membrane, and this is selectively permeable, or what we call semi-permeable, which means it allows certain molecules to enter or exit. So we can add water and solute molecules to both sides. So let's add some water molecules, and then let's add some solute. So semi-permeable means things like water can pass through. So water can pass through the cell membrane via osmosis from a high to low concentration, right? Solutes, however, are usually not able to pass through, and that can be due to things like their size or their charge. So here we have an over-exaggerated size cell so that we can see the cell in the solution here. The solution in the water is about 80% and 20% of the solute. And we have the definitions here. A hypotonic solution, hypo means below. So hypotonic means a solution with a lower concentration of solutes. A hypertonic solution is one that has a greater concentration of solutes. So here in the beaker, in the solution, we have 80% water and 20% solute. But in the cell, the solution in the cell is 60% water and 40% solute. So where is the hypertonic solution, hypotonic solution? Hypo means below, right? And so that's going to be one with the lower concentration of solutes. So the lower concentration of solutes is here. We have 20% solute versus 40% solute here. So the one in the beaker in this particular example is going to be the one that is hypotonic. So what would happen to a cell then that was placed into a hypotonic solution? A hypotonic solution. So this cell here is placed into a hypotonic solution. So we've got 80% water, 20% solute, which makes it hypotonic. 60% water in the cell, 40% solute, so that makes it hypertonic. So what is the definition here of osmosis? Osmosis is the movement of water from a high concentration to a low concentration. So where is the high concentration of water? Where do we have more water? Well, we have an 80% water in the beaker and 80% water in the cell. So water will diffuse it's going to go from high to low, and it's going to diffuse into the cell over time. Okay, it's going to go into the cell over time, and so the cell will gather water and keep going and swelling until it could eventually burst, and we call that lysis. We call that cell lysis. All right, so let's change the concentration to where we have 50-50 in the beaker and the cell is 60-40. Which solution would be hypotonic? The one with the lower concentration of solute. Which one would that be? Well, here we have 40% solute in the cell and 50% solute in the beaker. So the one with the lower concentration, the cell has 40%. So hypertonic would be the solution in the beaker. So the solution in the cell then is going to be the one that is hypotonic. It has less water, you should say, in it. So what's going to happen to a cell that's placed in a hypertonic solution? Remember, hyper means above. So let's remember, what is the definition of osmosis, right? Osmosis. It's the movement of water across a membrane from a high to a low concentration, right? So where is the higher concentration? All right, so the higher concentration of water here. In the cell, we have 60% water, and in the solution, we have 50% water. So water would go from high to low and leave the cell. It would diffuse out of the cell and cause the cell to shrivel or undergo what we call crenation. It would shrivel up. It would be crenated. And so remember that water follows salt. And when I say salt, I basically mean any kind of solutes. Water follows the solutes. And so when you think of the solute in high and low, it's going to almost kind of be opposite of the water. So we've got 50% water. Water is going out of the cell from a high concentration to low concentration. Okay? So let's take another look at that plasma membrane here and add some solutes. So here on the left, this is the intracellular environment. So this is intracellular. That means inside the cell. I can't get all the words on there. And this is extracellular. Okay? So this is outside of the cell. So this is the intracellular environment or intracellular fluid. And this side here is the extracellular environment or extracellular fluid. All right. So let's add 15 water molecules on the left and 5 solute molecules. That's inside the cell. And we'll have 5 water molecules on the right and 5 solute molecules. So which one is hypotonic and which one is hypertonic? So hypertonic or hypotonic? All right, so here on the left, we have 75% water and 25% solute. And on the right, we have 50% water and 50% solute. So does that help? I want you to stop and think. Which one of these is hypotonic? Which one has a lower solute concentration? And which one is hypertonic? Which one has a higher solute concentration? So if you chose hypotonic for the intracellular environment, you're right. And if you chose hypertonic for the extracellular concentration, you would be right. Okay, so let's look at this. We have 25% solute here and 50% solute here. So this would be the hypotonic solution, and on the right, the extracellular environment would be the hypertonic solution.